All right, so today we're going to start looking at what's called the law of sines. Okay, there's two laws we're going to look at this week. One is the law of sines, one is the law of cosines. Right? Basically, these formulas are used anytime you're trying to find sides or angles in a triangle and you don't have a 90. Okay, if you don't have a 90-degree angle, okay, it's called an oblique triangle. A couple things happen when you don't have a right triangle. You don't have a hypotenuse. Right? So we can't use right triangle trig, like SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. That doesn't work. We also can't use the Pythagorean theorem. Pythagorean theorem only works for a right triangle. Okay, so we're going to be looking at oblique triangles. There's really two different types you could have. If none of the angles are 90, you could have a triangle where they're all less than 90. Okay, that's an acute triangle. Or you could have a triangle where exactly one of the angles is more than 90. Okay, that's an obtuse triangle. When we sketch our triangles in class, they're not going to be to scale. We're just going to maintain a certain relationship between the sides and the angles we've done before, like keeping A across from alpha, B across from beta, things like that. Here's our diagram, okay, for solving right triangles this week. Names of the sides exactly the same as what we did 2 weeks ago. A, B, C. We've got alpha across from A, beta across from B. And now we have this new letter. Okay, we didn't have a letter here before. The reason? It was always a 90-degree angle. Okay, we just called it the right angle. So we didn't need to give it a name. Draw it a little bigger. But anybody know what Greek letter that is? Okay, that's gamma. It looks kind of like a Y a little bit, or like a bird or something. But it's gamma. And the only thing you have to know is that gamma is always across from C. Okay, that's important. Right, so just to try to show you like a sample problem where you might see something like this, whether it's a diagram or a word problem, we're going to look at an object that's not perpendicular to the ground. Okay, most problems we do, we talk about like a building, and we always assume the building is perpendicular to the ground. Well, there's a pretty famous building that's not a tower. It's not perpendicular to the ground. Anybody know what the name of that tower is? Yeah? Yeah, Leaning Tower of Pisa. Okay, so there's your Leaning Tower of Pisa. And if we were to try to make a triangle, okay, to solve this, well, we'd have something that would look kind of like this. That would be our tower. All right? And so that's kind of a line going down the middle. We'd have a horizontal, like that. And you can see here's the problem. The tower doesn't make a 90-degree angle with the ground. Right? Maybe it's, depending on which side you look at, maybe it's like 88 degrees or 92. Right? But the point is it doesn't come straight down like when we do a normal building problem. Okay, there's our building. Maybe we have a ladder leaning against it. We have a nice right angle right there. Okay, in this problem, we don't have anything that's vertical, okay, or straight up and down. Right, so we'll talk about how we could find the angle that the tower is leaning at, okay, and see. We'll actually compare it to what it's leaning at now to what our book says. Okay, our book's a little bit older, and I think it has the angle a little bit bigger than it really is, because the tower was actually starting to lean a little bit more each year. So they had to do something to kind of stabilize it. because for a while they actually closed it. You couldn't go in it, and tore it. So they've stabilized it. So they said probably for another 100 years or so, the angle that it's leaning at, it shouldn't change too much. Some people said, well, why didn't they just straighten the whole thing out? Well, then it wouldn't be the Leaning Tower of Pisa. So they still kept it at an angle, but just it's a little bit more stable. Has anybody ever been to the tower or seen it? It's pretty neat. If you ever have a chance, you can go in it. It's like a spiral staircase all the way up. It's a couple hundred steps. It's not too bad, but it's very narrow inside. It's probably no wider than 3 or 4 feet across, and it's the same stairway up and down. So for 2 people to get by each other, it can be a little tight, and it's all marble. I don't know if I can zoom in and if you can kind of see it, but all the blocks on that, it's all marble. That's not like a cement structure like we'd see, now in probably the United States. That's all made out of marble, and even the stairs inside are marble. But it's so old, and so many people have walked on the steps that instead of the stairs looking like that, they're all kind of concave from people walking on them. They're all like sunken in the middle. Forget the exact age of the tower, but it's pretty old. Not as old as like the Colosseum. That's almost 2,000 years old. But it's at least close to 1,000 years old, maybe more. It's pretty old. And we're actually lucky that it's still standing. 1, because it was starting to lean faster, and 2, this area during, I believe it was World War II, was hit by a bomb, some kind of missile. Something went off in this area, and a building near it. This is a giant courtyard. The whole roof was destroyed from another building. They fixed it, parts of it, to try to make it look original. But that was destroyed, but the tower wasn't damaged at all. So it's still there. Well, it's pretty cool if you get a chance to see it. All right, so depending on the information that you're given in the problem, it's going to tell you which law you need to use. Today we're only learning law of sines, okay, which I'll go through what the law is in just a minute. But if you're given either one of these cases, okay, these are law of sines problems. They give you 2 angles and the side that's between them. It's like the example I have on the left. You've got the 10-degree angle, the 105, and you've got the side that connects, the side that's between 2 angles. Or they could also give you 2 angles and a side, but a little bit different. In this case, they give you the 2 angles on the bottom, but they're giving you a side that's not between the 2 angles. Okay? Either case, angle, side angle, or side angle angle. Some people call it angle angle side. Same thing. You're using the law of sines. Right, and there's one more case you can use law of sines for. That's side-side angle. That'd be if they give you something like that. They give you 2 sides, and they give you an angle. The key is that the angle they give you is not the one where the 2 sides meet. Right? That would be something different. This would be something we'll look at probably on Wednesday. That'd be side angle side. Okay. This one, though, you got 2 sides, you got an angle, but the angle is not between the 2 sides. So they could have given you either this one or that one. And it would be side-side angle, just not the one at the top. Okay, any question on that? So you might have seen some of these letters before in geometry when you did proofs, but we're not doing proofs. We're just using these letters to explain the kind of problem you have. And that's going to tell you, is it law of sines? It's one of those. Or is it law of cosines? Which I'll tell you about those tomorrow, Wednesday. So to solve these, we're going to use law of sines. Okay, if I ask you to solve a triangle, what does that mean you need to find?
All angles and all sides.
Yep, all angles and all sides. And I'm always going to give you 3 of them. Okay. Might give you a couple angles in one of the sides, or a couple sides in one of the angles. But I'll always give you 3 pieces of information, and you've got to give me 3 pieces of information. All right, so let's take a look at what the law of sines is. Okay, start out with this diagram. In a second, I'm going to cover half of it. Okay, I only want to look at the left half for now. Then I'll look at the right half later. But I've got a triangle. Don't label anything more than I've labeled. Okay, I've got A and B for sides. Put A across from alpha. Put B across from beta. And then draw in that altitude. Okay, draw in the height from the top, perpendicular to the bottom. Okay, so when I started, I had a triangle like that. And then Ryan, when I add in that side, what have I just done? Yep, and what did that do to my big triangle? Yeah, and how many triangles did it separate it into? 2. So what we're going to do, we're going to focus on the left triangle for now. Okay, let's just look at that. Okay, as Ryan said, this is the height, so why don't we call it h? The only thing that could be confusing there is you might think it's hypotenuse, but let's call it h for height. All right. So focusing on this right triangle, I want to use one of my 3 trig functions, either sine, cosine, or tangent. I want it to involve that angle, that side, and that side. All right, so Chris, what's the name of the side that's farthest away from alpha in terms of like opposite, adjacent, or hypotenuse? Yeah, this is opposite. How about the side that's across from the 90? That's hypotenuse. Okay, anybody remember which trig function has opposite and hypotenuse in it? Sine. Yeah, we're going to use sine. Also proving the law of sine, so why not use sine? All right, so we get sine of alpha. And Brittany, what would that be? What's the opposite and what's the hypotenuse?
Tops, 90, or no, H.
H, yep. And the hypotenuse, that's across from the 90, that's B. Right, next thing I want to do is I want to get H by itself. So I want to move B to the other side. Mariah, how could I move B to the other side?
Multiply.
Exactly. Multiply by B. Multiply by B. And just leave that for now. So now you have a formula. The height equals B sine alpha. Any question on that formula? We're going to do the same thing again. Now we're going to look at the right triangle, or the triangle on the right. This time, I want to use a trig function that's going to involve that angle, this side, and that side. Katie, which trig function could I use that would involve the side that's farthest away and the side across from the 90?
Sine.
Yeah, I'm going to use sine again. It's opposite and hypotenuse. So the sine of beta equals opposite over hypotenuse. And I want to do the same thing I did last time. I'd like to get H by itself. So Holly, what could I do to get A on the other side? multiplied by A. Good. These cancel out. And I get another formula for H, a little different than the one I had on the other side. But they're both equal to H. Okay, what's in those boxes? Both equal to H. What does that mean? If what's in the box on the left equals H, and what's in the box on the right equals H, what else could I say? Yeah, the two boxes are equal to each other. Right? Two things equal to the same thing are equal to each other. In geometry, you might have learned something like that as the transitive property. If A is the same as B, and C is the same as B, well then A and C are also the same. So those boxes are equal to each other. So B sine alpha equals A sine beta. And that's pretty much our law of sines. Okay? All they do is they rewrite it a little bit by dividing each side by A times B and A times B. So what happens on the left is the B's cancel out. And what happens on the right is the A's cancel out. So you're left with sine of alpha divided by A equals sine of beta divided by B.
Wait, what did you have?
I divided each side by A times B because they don't normally leave it the way we had it. I'm just showing you, if you look it up in a book,
Oh, okay.
how the formula is going to look. You wouldn't know to divide each side by A times B unless I told you that. Right, so this is the first two fractions in the law of sines. Sine of alpha over A, sine of beta over B, and there's one more fraction. And it follows, if you can see the pattern. Anybody think they could tell me what the last fraction would be just by kind of looking at that pattern?
Sine gamma over C.
Yeah, perfect. Sine gamma over C. Okay. We didn't prove this part. We're not going to. I only proved the first two parts to you. But you could prove the third part very easily. Just draw in a height from a different side. Instead of drawing it from the top, draw it in from the lower right. And go through the same thing again. This is your law of sines. When you use this, you never use all three parts at the same time. You'll either end up using the first two parts, the last two parts, or you'll use the first part and the last part. Okay, so you only use two parts of this at a time. Has anybody ever seen this law before? Has already done this? No? Okay. So a good idea I think helps people out is when you're solving it, try to make a sketch. The sketch helps you just to visualize what's across from what. And then we'll make a table. Okay, if you don't want to make a table, you don't have to. The table is purely just to organize all our numbers. Okay, now we can't use the Pythagorean theorem anymore because we don't have a 90-degree angle. But there's still something that's true about all the angles. Anybody remember what that fact is about all the angles in a triangle? Ken?
They all add up to 180.
Yeah, they still all add up to 180. Even though you don't have a 90 anymore. They still all add up to 180. So we'll use that fact. All right, the tricky part about solving these kinds of problems, when we did this before, okay, you were able to find each piece of information separately. Meaning, if you got one thing wrong, it didn't necessarily affect you getting anything else wrong. Well, when we're using law of sines and cosines, that's not always the case. So if you make a mistake on one part, it is possible, depending on how you solve it, that messes up other parts. All right, so we just have to be very, very careful as we go through it. Okay, we don't want to make a mistake on one part and then end up with the whole thing wrong. All right, so this time they gave us our information. They didn't put it in a diagram, so we got to make a diagram. Because on the test, the first thing you'll have to figure out is this a law of sines problem? Or is it a law of cosines problem? At the very beginning of class, I went through the 3 types with you that were law of sines problems. Right, so in my table, I put A, B, and C in one column. Put alpha, beta, and gamma in another column. And let's make a diagram. So I'll put A across from alpha. I'll put B across from beta. And that'll be C and gamma. Right, so in terms of the 3 letters, like angle, side, angle, side, angle, side, whatever I have, I just want to know the type of triangle that this is. Right, so Carlos, what do you think? What kind of triangle is this? In terms of those 3 letters. And don't go by my drawing, because this might be totally inaccurate. Might not be to scale. All right, so you have a side. What else do you have? You have a side, and you have an angle, and you have an angle. Let's go back and look and see if that was... So you could say side angle, angle, or angle, angle, side. Same thing. It's this type. So this is one of the types that you use law of sines for. Right. Before we start to use law of sines, let's see if there's anything we can figure out here pretty quickly. Okay, without doing anything too fancy. Yep. Go ahead, Colton.
Gamma's 80.
Yeah, how do you know that?
Because all the angles inside have to add up to 180.
Right. Gamma's 80. And it's important you get gamma right. If you get gamma wrong, you're going to have to use gamma to find C in a minute. So if gamma's wrong, C's wrong automatically. You could still get B right. Okay, if you mess up gamma, that won't affect B, but it will affect C. Now you can find either B or C first. Okay, in this case, it doesn't matter which one you do first. But each time you solve it, you definitely want to use the row that has both pieces of information that were given. Okay? So you're definitely going to use that row to find B and to find C. Let's plug that first row into the law of sines. So we've got alpha and we've got A. So we're going to fill in this first part. Sine of alpha divided by A. So we've got sine of 40 divided by 4. Okay, the other thing I want to mention, you don't have to go back through and prove that formula again. This formula, just use it. You don't have to go back through the proof that I just had. Okay, that was just to explain where it comes from. Now what we put on the other side, depends if you want to find B or you want to find C. Let's do B first. So go back and look at the formula. And we're going to put sine of beta divided by B. Right, so Emily, what's beta in this problem? 60. So we're going to fill that in. Divide by B, we don't know. Okay, so this is a proportion. Very basic algebra 1 proportion. What's the technique you use to solve a proportion? You cross multiply. Just like that. So 4 times the sine of 60 equals b times sine 40. And my last step is to divide each side by the sine of 40. I don't know what the sine of 40 is, but I know it's multiplied by b, and I want to get b by itself. So to undo multiplication, use division. So that's gone. And that's your answer for b. Okay, we do need to plug it in and round it off. Okay, if you're using a calculator where you can switch between degrees and radians, it's important that you're in degrees all week. We will not be using radians this week at all. Okay, so there's the numerator, 4 sine 60. And I'm going to divide that by sine 40. Okay, so I get let's go to 3 decimals, 5.389. 5.389. Now we just have to get C, and then we're done. Okay, true or false? I can use the Pythagorean theorem to get C, now that I have A and B. You think, why is that false, Charles? This is not a right triangle. A squared plus B squared will not equal C squared. Not unless this was a 90. Okay. Okay. So we're going to find C exactly the same way we found B. Use law of sines one more time. Okay, Zach, which row do I definitely want to use to find C? Yeah, definitely. Okay, he could have said the second row because you've got both pieces of information. But B is something you calculated, so don't use it. Let's go back to the first row. So sine of alpha over A. And now this time, you're not going to put sine of beta over B. You're going to use the last part of law of sines, sine of gamma over C. Okay, and you go ahead and do your cross multiplying. If you can do the cross multiply step in your head, you know, it's what times what, divide by what, makes it a little faster. So I'm going to do it that way this time, and if you're not sure what I did, just let me know. I'm going to do 4 times sine 80. And then I'm going to have to divide by the sine of 40, because that's going to be multiplied by C. So I'm going to have to divide by it. It's basically exactly the same answer we got last time. Just change the 60 to an 80. Any question on how I cross multiplied and got that? All right, because I don't want anyone to get hung up on a shortcut. You know, that makes things harder if it's not really helping. All right, but that's just your cross multiplying. All right, let's see what we got. If you want to type it all in at once, you can. Just be careful with your parentheses. Sometimes if you type it all in at once, people mess up the parentheses. But you could type it just like that. That's to get 6.128. Okay, quick thing you should check, make sure the biggest side is across from the biggest angle. Smallest side should be across from the smallest angle. It doesn't guarantee that it's right, but if that's not true, I guarantee it's wrong. Okay, that can't happen. Okay, so it looks good. Biggest angle, that's the biggest side. Smallest angles with the smallest side, so I think things look reasonable here. Okay, and that's how you solve a angle, side, or side, angle, same thing, triangle. Okay, questions on that type? I'm basically just going to do one of each type. All right, so that's our first one. Okay, second one. This time they've drawn the diagram, so you don't need to worry about it. Makes it a little easier to tell the type of triangle. Okay, before I even try to calculate anything, I want to figure out, should I be using law of sines or should I be using law of cosines? Obviously, for tonight's homework, it's all law of sines. You don't know the law of cosines yet. Okay, Catherine, what kind of triangle is this one in terms of angles and sides? So I'm looking for those three letters to describe it. Yep, this is angle, side, angle. If you go back and look at the notes I gave you, this is one of the types we do use law of sines for. Now you might have noticed, to use law of sines, you've got to have a row in your table that's already complete. In the last problem, that was the top row. Well, in this problem, we don't have a row that's complete. But is there something that I could find that would make a row complete? Yeah. Yeah, what's this last angle? You want to remember how to say it? Gamma. Good. We can find gamma, and then we'll have a row that's complete, and we're good. So what does gamma come out to here? 95. Just take 180 and subtract 85. And you get 95. It's very important we get gamma right. We're going to use gamma to find B and to find A. So if we get gamma wrong, the whole problem's wrong. Nothing will come out right. So that's the key row. Okay? We don't have any other choice. We have to use it. It's the only row that has everything in it. So let's write that down first. Sine of gamma divided by C. And we know C. C is 4. Okay, let's find, let's do A first. Okay, Chelsea, how would I set up this right-hand side to find A? The sine of what over what? So look at your law of sines that has the A in it. And you're gonna, it has an A and it has an alpha in it. And you're gonna fill that part in right here.
Sine of 45.
Yep. Divided by?
A.
Exactly. And now we're just gonna cross multiply to solve it. So we get 4 times the sine of 45. That would equal A times the sine of 95. But then I'm going to have to divide everything by sine 95. Okay. Now we just plug it in and round it off. Any question on that? These two types, the one we just did and the one we're doing now, they're very straightforward. Same thing every time. So 4 sine 90. You got to type it in right though. So 4 sine 45 divided by sine 95. So this is close to being a right angle, but not quite. So if you did Pythagorean theorem, it would come out close, but wouldn't quite be right. So it's 2.839. Okay, now we're going to find B. Okay, I have a choice now. I have 2 rows that are both complete. I could use either one of them, technically, to find B. Which row, either row A or row C, which one do you think is better to use? Yeah? C. Right? It's not that everything was given, but at least the numbers are nicer. There's no decimals in row C. Okay? So that's another thing you want to avoid. Don't, if you can avoid it, don't use something you calculated and rounded off to find something else. Okay? So we're going to go back to row C. Sine 95 divided by 4. Equals. And Helene, what am I going to put on the right-hand side so that I can solve for B? Yep. Sine of 40 over B. So you've got 4 sine 40 equals B sine 95. And then you divide each side by sine 95. That's B. Okay, let's see. A and B should come out pretty close because alpha and beta are pretty close. So beta should just be a little smaller than, I'm sorry, B should be a little smaller than A. Okay? Not much, just a little bit. So about 4 sine 40 over sine 95. So 4 sine 40 over sine 95, it's 2.581. And that's it. Now, what if alpha and beta were the same? What would that tell you? That A and B are the same. Okay, I usually end up throwing a problem on the test that happens. And you should be able to do that one a little faster. If you got two angles the same, it's isosceles. You'd have to have two sides the same automatically. All right, so if you notice something like that, use that to your advantage so you don't have to do the same thing twice. Okay? Or even an even easier problem is if I said all the angles were 60. That's an equilateral triangle. Right? And if I gave you one of the sides, and I gave you all the angles, well, if you know one of the sides, you know all three. Because in equilateral, they're all the same. So that one you could do without any calculation at all. Any questions on angle, side angle? Second type. All right. Third type. All right. Third type is side-side angle. Right. You know a side, and you got an angle. Well, with side-side angle, we got to be careful with it. Okay, there's three possible cases. There's the case where you have one solution, okay, just a normal problem, two solutions, which isn't really harder, it takes longer because you just have to do everything twice, or no solution. All right, this is, bless you, this is the only case that you got to worry about this happening. Every other case we've done up until now, all the cases we're going to do on Wednesday, Tuesday, you'll never have this happen. Side-side angle is the only one. Okay, and the way I remember it is if you spell it backwards, this case can be a real pain in the, there you go. That's how you can try to remember it. All right, so let's try to solve this and see what happens. Okay, I've already got the diagram up above for you. A is 3, B is 2, alpha is 40. Now, in some problems, we had a choice. Maybe after you found an angle, you could figure out, okay, I want to find A or I want to find B. You had some options, which side you wanted to find. There's no options in this problem. you have to find everything in a certain order. Okay? Anybody have a guess out of C, gamma, and beta, what I have to find first? C? Well, if we find C, okay, that's the law of sines that has this part. Sine of gamma over C. Do we know gamma? Now, we don't know gamma, and we don't know C. So if you try to use row 3, you have 2 variables. We can only have 1. So which row, go ahead, Becca, what row did you say I have to use?
The first one, right?
Yeah, definitely going to use the first one
So you put
to,
gamma?
to find
Oh, beta.
beta. Yeah, we got to find beta first. Okay, there are no options. You have to get beta first. Right, so as Becca said, first row, sine of 40 over 3 equals sine of beta over 2. What's different about where the variable is compared to like some of the other problems we've done? Yeah, the variable, it's in the trig function. Okay, you can think of it, it's inside the sine function. Right, so let's try to start to solve it and see what happens. So we'll cross multiply. 2 sine 40 equals 3 sine beta. Next, I can at least move the 3 to the other side by dividing it. Now we have 2 times the sine of 40 over 3 equals sine beta. But I don't want to know sine beta, I want to know beta. So I want to somehow get rid of sine. Okay, we've talked about this before. What can you do to both sides that would cancel out sine? Yeah? Exactly. You got to do the inverse sign. Some people say divide by sign, but sign's a word. It's a function. You can only add, subtract, multiply, and divide by numbers and letters. Okay? Not a function name. Okay, so that was said perfect. Okay, you got to use the inverse sign. And inverse sign. We had a formula just like this a couple weeks ago. When you have inverse sign and regular sign, they cancel out. So beta, just type that in. See what you got. When we type this in, we're about to find out at least if this is a no solution problem or one solution. We won't know if it's 2 yet, but we'll be able to figure out if it's at least a no solution or there are solutions. Okay. Inverse sine of 2 sine 40. Divide by 3. Be very careful if you don't close that parenthesis. It's going to mess up. Okay, so we get 25.374. This is not no solution. If it was no solution, my calculator would have just said something about an error. Okay, we'll see one of those tomorrow. All right, so we have at least one solution. So what I'm going to do is write it up higher in the box, just in case there's a second one. And if there's a second one, I'll put it right below it. If not, then I won't put anything there at all. All right. Now, how do we check if there is another answer? Well, first you got to take the end. You got to get the 25.374. Any questions on how we just got that? So if there's a second answer, take what you just got for beta and subtract it from 180. Okay, if there's a second answer, that's what it is. So let me do that. Let me take 25.374 and subtract it from 180. if there's a second answer, that's what it would be. Okay, I haven't figured out yet if that's actually going to work in this problem. But if there's a second answer, that's what it has to be. 154.626. So let's just write that off to the side. So we call this is like our candidate. This is our candidate for the second answer. How do we know if it actually works? Well, see if it's possible to have that angle, the 154.626, and the angle we were given at the very beginning of the problem. See if they would fit in the same triangle. By fit, I mean they can't add up to more than 180. All right? So we're going to take our candidate for the second answer. Let's go back up and look at what was given and see if you could fit them in the same triangle. All right, so we were given 40-degree angle. We know the 40 is right because it was given. Is it possible to fit a 40-degree angle and 154 in the same triangle? What do you think, Zach? No. If you add 40 to this, you get 194.626. That's too big. Okay. So the second answer, this 154.626, it doesn't work in this problem. It's too big. If it had come out a little smaller, then maybe it could have worked. But in this case, it came out too big. Right? So I just explained what we went through. So if there's another answer, subtract what we got from beta from 180. This 154, that's your candidate for the second answer. But you were given a 40-degree angle to start. So if you try to add what you think could be the second answer to what was given, it's too big. It doesn't work. Now, if you added it to a number and it came out to less than 180, you would have been good. It would have worked. We'll go through a problem like that tomorrow. Okay, for today, the second answer will not work. So this is going to be a normal one-solution problem from here. So any question how I got the second answer or how I figured out it was too big? All right. So now we know beta. It's 25, what was it? 25.374. Damiana, what can I find next? Yeah, I can get gamma. I know two of the angles. Add them up and subtract from 180. Or just subtract each one from 180 one at a time. So subtract 40. Subtract 25.374. That means gamma is 114.626. Now I finally have a piece of information in that last row, which allows me to get C. Okay? If you're missing everything in a row, you're stuck. Till you get something in that row, you can't use it. Now I can use it. So I'm definitely going to use the last row to find C. And what other row should I use? Row A or row B?
A.
Yeah. Why is A better than B?
It was given.
It was given. We know it's right.
How'd you get 114?
114? So add these together, you get 65.374. And then subtract from 180. Because all the angles have to add up to 180. All right, so let's finish up and find C. So we're going to start with sine of 40 over 3. Equals sine 114.626 over C. Notice you're not going to have to use inverse trig here. The variable is not inside the trig function. It's in the bottom by itself. So just do your normal cross multiplying. So 3 sine 114 equals c sine 40, and then divide each side by sine 40. And that's c. Okay, before I even type c in, I'm just going to go back and look at the numbers I have so far. So when I get c, I can tell if it looks reasonable. So I'm going to scroll back up. C is the biggest angle by far. I'm sorry, gamma is the biggest angle. So C should be the biggest side, but it can't be any bigger than 5. It's impossible. Because if you add any two sides together, they always have to be bigger than the third. So I guarantee you it's less than 5, but it is bigger than 3 and 2. Right? So that kind of narrows down where it's going to be. Right, let's type it in and see. So 3 sine. I'll come back in a second and show you what happens if you don't close that parenthesis. So 114,626 divided by sine 40. So 4.243. All right, if you didn't close it, what it's going to do is take the sine of, and it's going to do 114.626, divide that number by the sine of 40, and then take the sine of it. You get a totally different answer just by accidentally leaving off a parenthesis. So if you're not sure, you're not comfortable with all the parentheses, do the problem one step at a time when you type it in. Okay, just do it one step at a time. Okay. So, any question on the side-side angle type? Okay, so those are the 3 types you'll have with law of sines. Tomorrow we'll look at the 2-solution case, and I'll draw a picture so you can see how it happens visually, and then the no-solution case, and I'll try to draw a picture of that too. All right, so the homework, it's on 266. Okay, it's all odds. 9 to 13, 17 to 21, and 25.